Good evening, families. Today we're going to learn about multiples and how factors and multiples are related. You're going to take notes on your Flipbook, so go ahead and take that out. If you don't have a Flipbook, just take a sheet of notebook paper or printer paper, fold it in half, and then on the top flap, you'll cut up so that you have two flaps, one to write notes for multiples and one for factors. Take a look at this example. It's a great preview for multiples and factors. 3 times 4 equals 12. 3 and 4 are both factors. They're numbers you multiply. The product of that, 12, is a multiple of both 3 and 4. Our unit goal is how do patterns help me find factors in multiple? And in this lesson, we're learning specifically how factors and multiples are related. Let's go ahead and make a flipbook, starting with the side that says multiples. What is a multiple? Is there a word that you know, that you think of when you hear that? It sounds kind of like multiply, right? The first thing I want you to write on your flipbook is that a multiple is formed by multiplying a given number by the counting numbers. Counting numbers are just 1, 2, 3, 4, and you can keep going. The second thing I have for you to know about multiples is that multiples always get bigger than the number. The next thing to think about is an example. Here are some multiples of 8. 8, 16, 24, 32, 40. So listing multiples is as easy as skip counting by that number. And you can think of 8 times 1 is 8. 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40, and we could keep going. Go ahead and make sure your multiples tab is complete with the definition for multiple, an example of the counting numbers, the big clue, multiples always get bigger than the number, and the example for multiples of 8. Pause the video if you need to. Now let's think about factors. We already know about factors, but let's take some notes so that we don't confuse them with multiples. Factors are the numbers that you multiply to get a product. The big clue for factors is that factors start smaller than the number and end at the number. You cannot have a factor of a number that is bigger than the number that you started with. So, 1 times 8 is 8, and 2 times 4 is 8. So the factors of 8 are 1, 2, 4, and 8. Make sure on your flipbook you have the definition for factors. That important clue, factors start smaller and end at the number, and the example for the factors of 8. Pause the video if you need more time to complete those notes. Replay when you're ready to go on. Here's an example for multiples of 4. Since 4 times 1 is 4 and 4 times 2 is 8, and so on, we can list the multiples of 4 as 4, 8, 12, 16, 20, 24, and 28. Here's an example for the factors of 4. I can multiply to get 4 by doing 4 times 1 and 2 times 2. So the factors of 4 are 1, 2, and 4. Let's do an example together. On the back of your flipbook, copy this example. Let's see. Factors of 13. Well, I can get 13 by doing 1 times 13. But if you remember, 13 is a prime number. That means it can only be multiplied by 1 in itself. So the only factors of 13 are 1 and 13. To list multiples of 13, I think about multiplying or skip counting by 13. The first multiple of 13 would be 13. The second multiple of 13 would be 26. The third multiple of 13 would be 39. The fourth multiple of 13 would be 52. What would the fifth multiple of 13 be? Try to figure it out. Did you say 65? If so, you did a great job. What's important to learn from these problems is the difference between factors and multiples, so that you can look at a word problem and decide if you need to find the factors of the numbers or the multiples. Let's look at this problem. Toy animals are sold in sets of 3, 5, 10, and 12. Mason wants to make a display with 3 animals in each row. Which sets could he buy if he wants to display all of the animals? If you remember back in the common factors lesson, in that lesson typically we had the total number of figures that they had, and they were trying to arrange them in equal rows. We're still arranging figures in rows now, only this time I already know that he's going to display the figures with 3 animals in each row. Since I know he's going to put how many he's going to put in each row, what I need is multiples of 3. Because I know he can buy them in sets of 3, 5, 10, and 12. And I need it to be a multiple of 3 for him to use all of his animals and display them in rows of 3. That means that I need to know if 3, 5, 10, and 12 are multiples of 3. So I'm going to list multiples of 3. 3, 6, 9, 12, 15. And I know that I've gone higher than my numbers, so I don't need any more. 3, of course, is a multiple of 3, but 5 is not. 10 is not either, but 12 is. That means that Mason can buy the animals that are sold in sets of 3 or 12 and arrange his animals on rows of 3 without leaving any behind. Let's look at another example. When we did factors, we knew that a common factor was a factor of 2 or more numbers. We can also look at common multiples. A common multiple is a multiple of 2 or more numbers. Let's take a look at this problem. Tony works every 3 days, and Amanda works every 5 days. If Tony works June 3rd and Amanda works June 5th, on what days in June will they work together? I know that Tony works every 3 days, and he's going to start his work on June 3rd, and that Amanda works every 5 days, and she's going to start her work on June 5th. So first, I'm going to use the calendar they gave me and mark off the days that Tony's going to work. Tony's going to work on June 3rd, and then 3 days later on June 6th, and 3 days later on June 9th, the 12th, the 15th, the 18th, the 21st, the 24th, the 27th, and the 30th. Amanda's going to work every 5 days and start on June 5th. So Amanda's going to work on the 5th, the 10th, the 15th, the 20th, the 25th, and the 30th. The question is, what days will they work together? The only days that have both marks for Tony and Amanda are June 15th and 30th, making the answer June 15th and 30th. But of course, you're not going to be surprised to hear me say there's another way to do it. How would you solve this problem without the picture of the calendar? Since Tony is working every 3 days starting on June 3rd, you can list multiples of 3, starting with 3 for June 3rd. And since Amanda is working every 5 days starting on June 5th, you can list multiples of 5, starting with 5, and then look for the common multiples. Let's go ahead and list the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And since we're talking about a month, I'm going to stop at 30 because there's 30 days in a month. For Amanda, I'm going to list multiples of 5, and again, I'm going to stop at 30 since there's 30 days in a month. 5, 10, 15, 20, 25, 30. Now to find my answer, I look for the multiples that they have in common. I usually look at my larger number and see which ones are also in my smaller number. There's no 5 listed in the multiples of 3. There's also no 10. But I do see 15 in both. There's no 20 for multiples of 3 or 25 for multiples of 3. But I do also see 30 in both, telling me that Tony and Amanda will work together on June 15th and June 30th. It's time for your check. Go ahead and check online to complete the problems that go with this lesson. We'll review these problems tomorrow morning in class. Don't forget to read some Calvin and Hobbes before you turn the movie off. Have a great night.